on cross-site request forgery. Item A5 on the OWASP Top 10 in 2010. We ranked this risk as medium to high, and its fixability, generally speaking, as difficult, because it does take advantage of the way the web works. And we'll go into this explanation later, but the cause of cross-site request forgery is that when users are logged into a site, a hacker can force the user to submit certain actions without them knowing, things like transferring money or changing their profile. Users can perform actions they aren't aware of, hence that's why it's called forgery. And we're going to discuss some of the main defenses against cross-site request forgery, so let's begin. Now, cross-site request forgery is quite possibly the worst name in the world for a vulnerability. That being said, you can think of it like a person who's under hypnosis and he's made to do something that they don't have control over. In this case, the attacker says, "Give me access to your secret ingredient to the tasty ice cream." And because the victim is under hypnosis, he agrees and goes off and gets the secret ingredient without even knowing. And when he wakes up, it's as if nothing happened. Now, if you think that's a silly example, fine, fair enough. I accept your judgment. Let's take a typical example of a user who's logged into a bank, and we'll say a logged in bank session is green, as you see here. A hacker will use cross-site request forgery to exploit this user by placing known actions from the banking site, such as payment, transfer, etc., onto the malicious site. Now, the hacker doesn't have a valid session. Remember that. The hacker just creates this page. But what actually happens is the user has a session, right? Now, the key thing to remember here is when the user visits the evil site, there's going to be a bunch of cross-site request forgery links, pretty much one-click actions. Many web requests can be done in one shot, and the idea is for a hacker to get a user to click on a link using their session to execute these one-shot actions. And I'll tell you what I mean in the following slide. So remember that the evil site kind of just sits there on the internet, and it tries to trick bank users into loading links with preset actions. Now you might be wondering what one of these links look like, and this is what a one-shot action looks like. You can see that it's a payment action, and it has the to account to the hacker and the amount. Also note that this particular link actually exists on bank.com. Now when the user accesses the evil site, their browser will see the bank.com request, and it will then access the bank using this particular link, using its authenticated session. Remember, the user was authenticated in the first place. And since the hacker elegantly created a single link performing the pay action, the user's browser will access the page transferring the amount to a hacker without even the user's own interaction. And the reason the user never sees it is because it's initiated by the evil site, and most likely the hacker will force this action into the background. So to demonstrate a cross-site request forgery exploit and how it would work for most normal users, we'll take a real-time example of Megan browsing her favorite clothing site, cc.com, looking for some trendy fashion for the summer months. Awesome. Now, as she's browsing cc.com, she decides to multitask a bit and decides to check her email. Remember, she's still logged into cc.com, but she types in the URL for her email client. And lucky her, there's an email from the same website. This is a phishing email from a hacker going to a malicious site, and it's specifically targeting CC users. Now, Megan doesn't really know this because she only knows that she really wants this latest and greatest app for cc.com. So she clicks on this link. Remember, she's still authenticated to cc.com at this point. That's strange. Megan notices that she's been taken to this really odd site called Dr. Stems. This isn't the site she wanted to go to. But no bother. She doesn't think twice about it and suddenly closes this browser window. But little does she know, the hacker set up Dr. Stems specifically containing cross-site request forgery attacks for cc.com. How does this happen? What exactly happened here? And how did Megan just get hacked? When Megan loaded the Dr. Stems page, there were hidden image load commands that load URLs from CC. They looked like this, and since Megan had a previously authenticated session, both these two URLs will load in the background without any problems. You can see the first URL sets her shipping address. And you can see that, remember how I mentioned these one-click actions, where the entire request contains everything you need to know within one shot? And then look at this second request, an add cart item. And again, it's a one-shot action where it's adding 3 items to a shopping cart within the exact same URL. All the hacker had to do to execute these cross-site request forgery attacks was put these URLs into image tags, which would load the CC site using Megan's active sessions. After loading Dr. Stems, Megan doesn't think twice about it. She goes back to CC and decides, might as well continue my shopping. But loading the site, she notices strange things. There's been items added to her cart, and her shipping address has been changed. This is the result of cross-site request forgery. If Megan never loaded her profile, she might not have ever noticed that her shipping address had changed. Or if she purchased things, she might not have noticed that the shipping address was also modified so that the items would go to the attacker's address. Now, a smart attacker, of course, wouldn't mail things to his own address, but you get the point. Cross-site request forgery modified Megan's profile and added items to her cart without her ever knowing. So at this point, you might be thinking, Oliver, I still don't get it. What the heck just happened? Okay, let me do this conceptually. We know that Megan was logged into CC, right? So when she clicked on her email and clicked on the link within that email, it loaded the evil site from Dr. Stems. Now remember, she already had the authenticated green session here in the background, and using the exact same browser window without logging out, she started to access the evil site. Now the evil site contained cross-site request forgery links that targeted CC users. The minute she loaded the evil site, it started to use Megan's authenticated session to CC to execute the cross-site request forgery links. And since Megan's browser is actually accessing cc.com itself using those links, CC would never know that Megan didn't initiate these links herself, because they come from her browser, and it doesn't look malicious. It actually looks like Megan legitimately tried to change her address and add cart items. Tricky, huh? And this is why cross-site request forgery is pretty dangerous and a difficult thing to fix, because really, this is how the web works. So what are the key points that we just learned about cross-site request forgery? There's a couple key things that have to happen. The first item is that the victim must be authenticated. So Megan, in this case, had to have a session to cc.com and a recent session that was active. Cross-site request forgery relies on the user being authenticated in order for their URLs to work. And that's the second thing. A hacker must be able to make a URL that's what I like to call a one-shot URL. So it has to be an action that can be completely summarized in one URL. And most of these attacks are blind, right? An attacker doesn't know what kind of users will visit their site. They're just hoping that the user that does has an active session. And so the link often is very discernible. It looks something like this: a transfer from a certain account to a certain account for a certain amount. And with most cross-site request forgery URLs, you will be able to very clearly see what the request is about. Let's now learn about some of the defenses against cross-site request forgery. We'll be talking about decreasing session timeouts, tokens, and forcing reauthentication. So remember that in order for cross-site request forgery to work, a user has to have a valid session to the site that a hacker wants to take advantage of. In our example, we wanted to take advantage of Megan's account on CC. One defense mechanism that can be deployed against cross-site request forgery is to decrease the amount of time a user's session is active. That way, if a user forgets to log out but accesses other sites, it is less likely that their session will remain active when taken advantage of by a cross-site request forgery attack. So the next defense I want to talk about is something known as a cross-site request forgery token. The server will generate a token on each and every page load and then store it. Now when the user, you or me, sends the form back to the server, it checks if the value matches. It's a pretty simple solution. A hacker trying to take advantage of cross-site request forgery would have to know the token that the server assigned to you. In most cases, this would be near impossible, because remember, a hacker's relying on that one-shot URL, that one-shot form submission, which in most cases wouldn't have the element of randomness. Now, what a developer can do is that for each action that is sensitive, the server first generates this token that's unique to the particular request, and it'll be embedded into the form. So when the user submits the form, they must also submit this token back to the server, and it has to match. If it doesn't match, then we know that the user didn't come from the right path. The form could have been old, or it could have been submitted by somebody else. If we go back to our old example of cross-site request forgery, remember this example on cc.com where an attacker was trying to add 3 items to the cart. Now in this particular example, the token you see here doesn't match the token that was assigned by the server. And we know in this case that if we receive this particular cross-site request forgery attack, not to allow it because it wasn't submitted by the user because the token won't match. And this is why cross-site request forgery tokens are a pretty good defense against this particular form of attack. The last defense I want to discuss is reauthentication. You may notice that some applications ask users to reauthenticate for sensitive transactions. Maybe things like changing your profile or transferring a large amount of money. This is an excellent way of mitigating the risk of cross-site request forgery. And I'll tell you why. Since most cross-site request forgery attacks happen in the background without user interaction, asking for a user's password effectively blocks this type of attack from happening, since the act of entering a password itself will require some sort of interaction from the user. And what it also helps you to do is it helps you to verify that whatever action is being performed, the user is actually confirming their identity before you execute the action. It's kind of like showing your ID. So implementing reauthentication for sensitive transactions can help defend your site against cross-site request forgery attacks. It comes at the cost of a little bit of usability, but I think most of your users will appreciate it. Okay, great. We've now reached the end of this module and we learned a number of key defenses against cross-site request forgery. The first, implementing a shorter session timeout, is a simple defense, though not completely effective. It assumes that if we provide a shorter timeout on the site, the likelihood that your users will become victim to a cross-site request forgery attack will be lessened. We also discussed reauthentication and how reauthentication of more sensitive transactions can be a good defense. And this is because cross-site request forgery is usually most effective when executed without any user interaction. So the act of reauthentication itself checks that the user meant to perform the action in the first place, and we verify that with the user. Finally, the last defense that we had discussed was using anti-xsrf tokens. What you have to do is generate a unique token on each visit to a sensitive form. Now, when the form is sent back to the server by the user, the token has to match, or else the request is dropped. Now, the reason this works is tokens can't easily be guessed by an attacker. They can't be placed into a broad cross-site request forgery attack, so it makes it much more difficult to execute this type of attack against your forms. I hope you enjoyed this module on defending against xsrf.